In this video, we'll begin our discussion of section 14.6. This is over triple integrals. Don't worry, this isn't anything harder than what we have been doing. So let's start with a couple of straightforward examples. The first thing I am going to recommend to you is to write in your bounds. It does get very confusing in which one you're going to plug in. 6 equals 2. I know it's annoying. I know you don't want to, but trust me, you will make mistakes if you don't. Okay, so x is -1, x is 2. Picking these up, how you can tell, I just want to make sure you know, comes from this goes with the inside. This one, just like double integrals, this one goes with this one. And then the last one goes with z. So it's innermost first. All right, and I didn't change anything. All I did is write my bounds. So dx, dy, dz. Right, and we do one at a time. Okay, so I'm going to leave my z equals 0, z equals 2, y equals 0, y equals 1, and then we take it like just like the double with respect to that variable. Everything else is a constant. So we're dealing with x first. So I'm going to get 1/2 x squared y z to the third. And then now I know, this is why we keep our bounds, that I'm going to plug in x equals -1 to x equals 2, and then I still have dy dz. Okay, let's plug those in. I got z equals 0, z equals 2, y equals 0, y equals 1. Plugging my x's in, okay, I plug in 2. We get 2 squared is 4 divided by 2. So I get 2x, no x's, we just plug that in. Yz to the third minus, okay, we got to plug in a -1. That's going to get me a positive, okay, 1/2 yz to the third, dy dz. Should I plug that in? Yep. That minus comes from the minus in the integral. Okay, I can actually combine those, so we might as well. So z equals 0. It's a lot of rewriting. Z equals 2, y equals 0, y equals 1. And that's going to give me 3/2 yz to the third, dy dz. Right, now I can do y. So z equals 0, z equals 2, and then I raise my exponent up by a new one, so this becomes a 3/4 y squared z cubed from y equals 0 to y equals 1 dz. We're almost there. I'm going to drop these bounds because all I'm going to have are z's left. Okay, I plug in 1, I get 3/4 z cubed. Minus, if I plug in 0, I get 0. So that's all we have there. dz. Alright, I do now my integral. I go up by 1, divide by my new one. I get 3/16 z to the fourth from 0 to 2. If I plug in 2, I'm going to get a 16. I get a nice pretty 3 there. Okay, so that's how you do it. Just be really careful. The mistakes that I see are come from wanting to leave it like this with your numbers, and people mess it up. I messed it up. I actually didn't start labeling it until after I took Calc 3. My professor didn't label them either. I'm just telling you it's a good safeguard. All right, I got one more example for this video. All right, the bounds look a little crazier. They're not just numbers, but it's treated the same way. All right, so that first integral, so let's write all these in. The outer bounds go with the outer dy. So y equals 0 to y equals 9. And then we have an inner x, so x is 0, x is y over 3. And then we have it's going to be our z's because that's the innermost. So z equals 0, and z equals y squared minus 9x squared. We're just going to plug those in. Don't let it trip you up. Then you got dz, dz, dx, dy. Okay, cool. Now I can do this. It's a lot of rewriting. It's the most annoying part. Y equals 0, y equals 9, x equals 0, x equals y over 3. We can go ahead and run this integral. This is 1/2 z squared from z equals 0 to z equals the square root of y squared minus 9x squared dx dy. right? It actually most of the time works out nicely. Notice when I plug that square root into that square, it's going to undo itself. So y equals 0 to y equals 9. And then we have x equals 0 to x equals y over 3. All right, we're plugging each one of those in. I got 1/2 times y squared minus 9x squared. Dx dy. All we did was plug in z equals that big expression, and then plugging in 0 is just going to get us a 0. Right, now we can integrate that with respect to, I'm going to pull the 1/2 out. So y equals 0, y equals 9, and I'm going to put the 1/2 right here. Okay, and then we have to integrate with respect to x now. So this gets xy squared minus 3x to the third, and then x equals 0 to x equals y over 3 dy. All right, so now we just have to plug those x's in. I'm going to drop my y's there because we don't need it. We only have one now. Okay, I'm plugging in x equals y over 3. The zeros are going to make everything 0 out, so that's good. I get y over 3 for x, so I'm going to get y cubed over 3 minus, if I plug in that, I get y cubed over 20. One of those 3's are going to cancel. I'm going to get 9 on the bottom, and I get y cubed for that. All right, dy. We can simplify that. I'm going to pull the half out, and we can get a common denominator. So we get 3, if you do this off to the side, 3y cubed over 9 minus y cubed over 9. Notice I can pull the 9 out, which is going to make this an 18. And then 3y cubed minus 1y cubed is 2y cubed. I could really just pull that 2 out as well if I wanted to. All right, this is still ran from 0 to 9, dy. Okay, I got 1/18. I raise it, I go by 4. Divide by my new one, so I get 2 over 4, which is 1/2. Y to the 4th. And they want to split 0 and 9 in. All right, we're going to get 9 times 4, that's 18 times 2. You'll see why I'm doing this. 9 times 9 times 9 times 9, that's 9 to the 4th. Cancels there, and I got 9 to the 3rd over 4, which is 729. So that is the volume caught in between. These are the same rules that we've been doing, same in double. The hardest part is keeping them straight because you have 3 now. We could add a 4th if we wanted to. This is finding volume, depending on what we're looking at and the way that it is set up. So we'll take a look at how to do some problems involving volume now.